So the next section is a topic of chapter 5-4. So it's all about analyzing graphs of polynomial functions. So now we're going to be looking at some terms that you need to know having to do with relative maximum, relative minimum. So that's just looking at where the greatest or the highest point of a graph is, the lowest point, etc. Based on the y coordinates. So that's something that we're going to be looking at in particular graphs. And then if you have any turning points, that's also something we're going to be looking at. So where the graph, goes from maybe increasing then to decreasing and so on. So we're going to be looking at that as well. And if you have any extrema, that is any what your maximum and minimum values of a function might be. Because remember, you've seen now some they start curving and then they have like another little dip and then maybe curve high and then low and so on and so forth. So those are some of the terms you'll be seeing. So let's go look at your packet. So in your packet, you're going to be, this is section 5-4, analyzing graphs of polynomial functions and some examples. And if you notice here, you're going to be repeating some of the things you've done, but it's, instead of just being very simple like linear or quadratic, now you're going to be looking at these polynomial functions. So locate the zeros, not to forget that zeros are where the graph crosses the x-axis, your x-intercepts, roots, solutions. And so sometimes you won't have an exact number. Is it 0.5? Is it, no, so don't worry about that. Just say, you know what, the zero is between, like in this case right here, -2 and -3. There's another zero between, 0 and 1, etc. So that's that you can do as well. There's some more examples there. They ask you to find maximum and minimum points. Well, normally that's easy to see certain things if you make a table of values. So that's basically what you're going to be doing with these plug in numbers. And so they'll usually tell you, if you notice, you go from, for sure, see what's happening at 0, -1, +1, 2, 2, 2, -2, 3, -3, up to maybe 4, -4, just to get an idea of where your graph, kind of is going up, going down, etc., to get a better a picture, and so you can graph it and so on. Then there's some story problems there for you to do. So we go ahead and look at your study guide and notice how it tells you there. So make a table of values, but look what it says. It says to determine consecutive integer values of x. Whoa. Consecutive integer values. Let's make sure we understand what that means. So consecutive, next to each other, 1, 2, 3, don't start skipping x is 1, x is 50, x is 7, no, just consecutive. They were next to each other, just like they did here in the sample one they gave you. And then integers, so you're doing whole numbers, right? The negatives and the positives. So it's always good to see what the parabola is doing, especially if it's quadratic or any graph that they give you. What's happening at 0, what's happening near 1, 2, -1, -2, etc., so that you can just get a nice little picture of if it's going to change, go up, down, etc. And so they tell you to do that, to find the zeros as well. Most of the time you can find the zeros by looking at the table, but in this case, if it's not an integer, then the zero is a little harder to find, and so you pretty much have to sketch it, kind of get an idea. But look at this. If you could at least say, you know what, the zero is between this number and this number, then you're okay. It doesn't have to be exactly precise, just a little, kind of to get an idea. All right, so let's go ahead and do one of these. What I'm going to do is, just to save time, since I'm having to record these videos, I'm going to go ahead and use a calculator for these, but you're going to, if you don't have a calculator, of course, do it by hand. It's always better to practice by hand. So let me just grab my calculator and punch one of these in and see what the table looks like. So let me see if I can get, I can get most of the calculator in your view. Okay, so let's do question number 2. So I'm going to go to the graph. Let me make sure that I've got tab. I think I was doing a relation here, so I'm going to clear it so that we can do just a regular equation. So, or I tell it menu, I want a graph, so a function. So I'm going to tell it menu 3, 1, and that gives me this right here. So I can just punch it in. So here we go. Sorry, I'm going to have to move it a little bit so that I can see the numbers down here as well. Okay, so x to the, okay, so now to put to the 4th power, you can either use, that's probably the simplest, the little caret here, it's like, looks like a little roof, that's raising it to that power, so that's all you have to do is that. and then plus 2x to the third power. And notice how the same thing, whoops, but I did a little mistake. I did get out. So to get out of it, just press arrow to the right. See how now the bar is big? It's not there, like it's not an exponent anymore. So now I can, oh, sorry, I forgot the plus 2x to the third power. And remember, I'm at the exponent, so I have to get out. So there I'm out. And then minus 5. So I've got my equation. I press enter, and that's what it looks like. So you do notice there is kind of a dip here. It changes, then it goes this way. So it's asking me to do several things. So I'm going to look first at the, I'm going to go, sorry, not tab, but control. So I'm going to go control T, and that'll give me the table. And remember, it asks you to get some of these numbers and write them down. And so here's my table of values. So I can already see what's happening a little bit here. It looks like at most, oh my gosh, look at this. It's going to go on and go to infinity on the negative side. And look at that, the same thing on the positive side. But I do notice some interesting things that happen here. So that's what you want to take note of. So let me go ahead and show you. There you go. So that's pretty much what you're going to be doing. Of course, we want to look at some of the important points on this thing. If you notice, the y-intercept looks like it's right here. And yeah, we can verify it by this, right? So when x is 0, y is -5. And that you could see from the actual equation here. So I know for sure, let me just move this over a little bit. So I know for sure that I'm going to be crossing at -1, -2, 3, 4, 5. So if this is -5 right here, the graph is definitely going to cross there. Let me go back to what I saw in the calculator. And remember, if you don't have a calculator, you could always use a Desmos program. So if I made a table of values, I could see all those things right there. If you notice, it looks like it's going to have an intercept somewhere right here. So let me take off the, I'm going to take off the table for just a sec, just so I can see. So control T, so I can just see the graph. And if you notice, I do know that the intercept is here. And then it has this, it looks like a minimum close to, so this was 5, 6, about between 6, -6 and -7. So, and then it comes over about 1, 2, possibly 2 maybe. So I can go see the table and see what's happening at that point. So we said at about -2 on the x, so I'm going to come this way. So at -2, it looks like it's coming here down at about 5. So a little bit less than that, maybe -1. You see how it's lower at -6, and then it jumps back to -5. So I can also graph those points. So let me get this out of the way. So we said that at -2, it was at -5. Then at -1, it dips to -6. And then at 0, it's -5 because that's our intercept. And at 1, it's at -2. And then remember, we said that it's crossing at about a little bit more than 1. And then it's -2, -1, -2, and it somewhere here. So now if I try to graph this thing, let's see how good I can get to recreate it. So it looks like it comes down like this. It does something like here, it kind of levels off a bit, goes to, looks like here, it does something like, oops, let's see, this, and then it comes up like that. And here it has like that little kind of constant, goes down here, has a little tail, and then does something like that. Now, I'm sorry, it's you on your paper with your pencil, you can make a way smoother curve than I did. It's just I'm using the stylus for my computer, and so sometimes it's a little bit hard to see that. So let's go back. Let me put it over here. Let me move me out of the way. Notice that's what you pretty much see. Calculator, sorry, it's not as pretty, but at least that's to give you an idea of what you need to do. So see how if you draw a table, I just plotted the points of what it should have. You can use the Desmos program if you don't have a calculator to try to get an idea of how to use some of these um, features right on there and stuff. Okay, so that's pretty much what you're going to have to do here to graph these functions, kind of draw a little table. And then it says determine the x between which real zeros, so between 1 and 2. So you don't have to be precise, just kind of un más o menos, get an idea, and you should be fine. And the rest of it continues. Read the example here. It shows you, here we go. So now the way you find the maximum and your relative minimums is you're looking at the spots where it's the highest value, and of course the minimum would be the lowest value. So there, if you notice, you just say a relative minimum occurs at x is -4, and a relative, maximum occurs at -4. A relative minimum occurs down here, which is at x is equal to 0. So that's the only other thing you have to do is graph the functions, then try to estimate where you have your relative max, relative min. And again, you can get an idea in the calculator, or of course, create a table of values. What I would recommend definitely is do a little table, and for sure look at, maybe go up to -3, -2, -1, 0, 1, 2, 3, and see what's going on. Unless you notice something really like a big number, but I think most of these are pretty standard. Here, let me just give you a hint. If you're like, well, where's the y-intercept? There's no number. Well, remember, if there's no number, you can set a 0 because it's nothing, right? So this one, you're guaranteed your y-intercept. This particular graph, whatever it looks like at the end, is going to pass through that point.